Student, in previous video I have discussed property of determinant and related problem, how to solve problem of determinant. In this video I am going to teach you adjoint of a matrix, inverse matrix, similar matrix and non-similar matrix. So first of all I will discuss how to find adjoint of a matrix. किसी मैट्रिक्स का एडजॉइंट हम कैसे निकालेंगे, इसके लिए हम फर्स्ट ऑफ ऑल आई एम गोइंग टू गिव कॉन्सेप्ट स्टूडेंट्स. सो फॉर एडजॉइंट ऑफ मैट्रिक्स, सपोज आई एम टेकिंग ए मैट्रिक्स A of order 3, A1 1, A1 2, A1 3, A2 1, A2 2, A2 3, A3 1, A3 2, A3 3. It is a square matrix of order 3. So it is R1, it is R2, R3, column 1, column 2, column 3. How to find adjoint of this matrix? So to get adjoint, we will find cofactor. We will find cofactor. Cofactor of A11 is C11. Cofactor of A11 is C11. Cofactor of A12 C12 and cofactor of A13 C13 and cofactor of A21 C21, cofactor of A22 C22, cofactor of A23 C23, cofactor of A31 C31, cofactor of A32 C32, cofactor of A33 C33. So these are the cofactors. So we first find cofactors of the corresponding elements. We find cofactors of corresponding elements and we make a matrix B. B matrix will be made by taking cofactors of each and every element. It is replaced by cofactor C11, C12, C13, C21, C22, C23, C31, C32, C33. It is a matrix of cofactor, V matrix. Now we take transpose of this. So adjoint of A matrix is B transpose. B का transpose adjoint of A. So B transpose means we take first row of this in first column C11, C12, C13, C21, C22, C21, C22, C23, C31, C32 and C33. This is the adjoint of A matrix, transpose of B. So first of all, to find adjoint of a matrix, student, first we find corresponding cofactor, elements of cofactor find कर लीजिए. Now after finding cofactor, we will make a matrix B of cofactor. This is replaced by cofactor. This is replaced by cofactor. So it is a B matrix of corresponding elements of cofactor. So adjoint of A matrix is equal to B transpose. इसका ट्रांसपोज लीजिए, फर्स्ट रो को फर्स्ट कॉलम, सेकेंड रो को सेकेंड कॉलम, थर्ड रो को थर्ड कॉलम में कन्वर्ट कर दीजिए, adjoint of A होता है. This is the concept to find adjoint of a matrix, student. So this is the adjoint of a matrix. Now I am going to discuss, student, what is singular matrix and non-singular matrix. What is singular matrix and non-singular matrix? Singular matrix. What is singular matrix, student? I am going to give concept. A square matrix whose determinant is equal to 0 is called singular matrix. A square matrix whose determinant is equal to 0 is a square matrix. A singular matrix. A square matrix is called singular matrix if determinant of A is equal to 0. A square matrix A is called singular matrix if determinant of A is equal to 0. singular matrix स्क्वायर मैट्रिक्स होना चाहिए. जो स्क्वायर मैट्रिक्स है उसी का सिंगुलर हो सकता है. सो स्क्वायर मैट्रिक्स इज कॉल्ड singular matrix if determinant of A is equal to 0. non-singular matrix. A square matrix A is said to be non-singular matrix if determinant of A is not equal to 0. Non-singular matrix, square matrix is said to be non-singular matrix if determinant of A is not equal to 0. That type of square matrix is called non-singular matrix. Only non-singular matrix has its inverse. Only non-singular matrix has its inverse matrix. जो मैट्रिक्स नॉन सिंगुलर होगा उसी का इनवर्स एग्जिस्ट करेगा. जो नॉन सिंगुलर नहीं है उसका इनवर्स एग्जिस्ट नहीं करेगा. सिंगुलर मैट्रिक्स का इनवर्स नहीं होता है, नॉन सिंगुलर मैट्रिक्स का इनवर्स एग्जिस्ट करता है. सो दिस इज द सिंगुलर मैट्रिक्स एंड नॉन सिंगुलर मैट्रिक्स. इफ इट्स मैट्रिक्स इज नॉन सिंगुलर then we can find inverse. So inverse of non-singular inverse matrix inverse matrix of A is equal to adjoint A by determinant A. This is a formula to find inverse. If adjoint A is C11, C12, C13, C21, C22, C23, C31, C32, C33, this by determinant A. This is the inverse. Inverse of A matrix is equal to this. This is a formula by which we find A inverse of non-similar matrix only. Similar matrix has no inverse. So this is a formula for finding inverse of the matrix. There is some property of adjoint matrix. There is some property is of adjoint matrix A into adjoint A and adjoint A into A is equal to IN into determinant A. IN between determinant A, where A is a square matrix of order n. If A is a square matrix of order n, then A into adjoint A into A, unity matrix into determinant A. Into determinant A is a formula, property. If A is a square matrix of order 3, if A is a square matrix of order 3, then order 3 A into adjoint A and adjoint A into A is equal to I3 into determinant A. So unity matrix accordingly, which if A is a square matrix of order 3, then here I3. If A is a square matrix of order 4, here is I4. If A is a square matrix of order 2, it is I2. In this way we can prove this property. This is the property of adjoint matrix. So this is the thing. Now I am going to solve question related to this. Question related to this. Suppose here is a question, one question I am going to discuss. Suppose what a matrix A is 1 3 1 minus 1 1 0 2 minus 2 3. It is a square matrix of order 3. Then verify A into adjoint A and adjoint A into A is equal to I3 into determinant. We have to verify this. This is the problem I am going to solve before you. How to solve this problem, student? Just to see the method process, how we can solve this question. Solution, student. Solution. First of all, we find determinant of A. Determinant find करेंगे. Determinant 1 3 1 minus 1 1 0 2 minus 2 3. Find determinant for this. So first we find cofactor of this C11. C11 की वैल्यू निकालेंगे and C11 this cancel 3 minus 0 C11 3 C12 ये माइनस हो जाएगा इसके आगे नेगेटिव. So here is a cofactor of this row cancel 9 minus 2 plus 2, so minus 11. This one C12. Then we find C13. So this cancel 3 into 0 0 minus 1, so minus 1 C13. Then find C21 minus it is odd 2 plus 1 this row cancel this column cancel, so minus 3 and 0, so it will be 3. C22 cofactor of this row cancel this row cancel, so 3 minus 2 3 into 1 3 or minus 2, so it will be 1. C23 minus C23 cofactor of this row cancel 0 minus plus 1, so minus 1 cofactor. Now find C31 cofactor of this row cancel 2 and minus 2 0. This one. Now C32 minus C32 cofactor of this row cancel minus 2 or minus 6 minus 2 or minus 6, 8, it will be 8. C33, cofactor of this cancel, 1 plus 3, 1 plus 3, that is 4. So these are the cofactors of all the elements, corresponding elements. So we will have now find adjoint of A. So adjoint of A, you arrange this in column wise. First column, 3 minus 11 minus 1, a first column. Second, 3 1 3 1 minus 1 and 0 8 4. This is the adjoint A. This is the adjoint A. Now we simplify this. Do simplification of this determinant. So 1, this cancel, 3 minus 0 and minus plus 1, this cancel, 9 and minus plus 2, this cancel, 9 plus 2 and plus 2, this row this cancel, 0 minus 1, so 3 not 11 minus 2, so it will be 12. Determinant A is 12. Now we verify this. A into adjoint A, and this will verify verification. So we will find A into adjoint A. Now we will find A into adjoint A. A is 1 3 1 minus 1 0 2 minus 2 3 and adjoint A 3 0 minus 11 1 8 minus 1 4. So do multiplication. So what are we getting? Multiply this. Do multiplication, students. Multiplication. It is multiplication is possible. So this row and this column. So 1 into 3 plus 11 and minus 2. 1 into 3 minus 1 and minus 2. 1 into 0 and minus 8 plus 8. So it will also 0 and 12 0 12. You are getting A into adjoint A. So A into adjoint A, we are getting 12 0 12 12. It is A into adjoint A. So what are we getting? We see that further. Further we see that A into adjoint A, if we take common 12 into 1 0 0 0 1 0 0 0 1, so A into adjoint A 12 modulus A 12 in modulus A, it is I3. Similarly we can prove adjoint A into A is equal to determinant A into I3. So this property is verified for this square matrix A. So this is the process to verify this property. A into adjoint A is equal to adjoint A into A, determinant A into, if A is order 3, I3. So this is the thing. Now we come to inverse matrix. Here previously we have discussed regarding finding inverse matrix by multi-row transformation or multi-column transformation. Now here we will find inverse matrix with the help of adjoint. With the help of adjoint of a matrix, we will find inverse matrix. So inverse matrix, if A is a square matrix which is a square matrix which is non-singular, then there exists a matrix, a square matrix B of same order, such that A into B and B into A is equal to unity matrix of order n. Unity matrix, I am unity matrix of order n, where A is also a square matrix of order n, B is also a square matrix of order n. If A into B into A in, then A inverse is equal to B and B inverse is equal to A. This is the concept of inverse matrix. If A into B matrix into A in, so A inverse is equal to B matrix, B inverse is equal to A matrix. Now, as you know, just A inverse, if you want to find A inverse formula, A inverse is equal to adjoint A by determinant A. This is the formula to find A inverse. Now some properties of inverse matrix will see, it will be useful in solving the problem. Some properties of inverse matrix. Properties of inverse matrix properties of inverse matrix of inverse matrices. First property, if n be are invertible square matrices, if the same order AB also, if first reversal law, if A and B are invertible invertible square matrices of the same order, then AB inverse is equal to B inverse into A inverse. AB inverse is equal to B inverse into A. This is reversal law of inverse matrix. Second, student, second law. Second, if A is an invertible square matrix, A is invertible square matrix, and A transpose is also invertible, and A transpose is also invertible, then A transpose inverse is equal to A inverse transpose. A transpose inverse is equal to A inverse transpose. It is very important property. Now, property third, if A is an invertible symmetric, then A inverse is also symmetric. A inverse will be also symmetric. Now, property fourth property, A and B are non-similar matrix. If A and B are non-similar matrix, then adjoint of AB matrix, product adjoints of AB matrix is equal to adjoint of B into adjoint of A. Adjoint of B into adjoint of A. This is the property. So adjoint of AB is equal to adjoint of B into adjoint of A. Next, for any square matrix, next property, for any property 5 for any square matrix A, prove that S1 matrix A adjoint of A transpose, adjoint of A transpose is equal to adjoint of A transpose. A transpose adjoint. Adjoint of transpose is equal to adjoint of A transpose. Fifth property. Now that is sixth property. If A is a non-singular matrix, is a non-singular matrix of order n, then modulus of adjoint A, determinant of adjoint A is equal to determinant of A n minus 1. If it is non-singular matrix of order n, so determinant of adjoint A is equal to determinant A to the power n minus 1. It is very useful. It will come in 1 marks, best questions upon these properties. So these are the property. Last property 7. If A is a non-singular matrix, if A is a non-singular matrix of order n, then adjoint of adjoint A is equal to determinant A n minus 2 into matrix A. Determinant A n minus 2 into matrix A. Adjoint of adjoint A is a non-singular matrix of order n. Then adjoint of adjoint A, determinant A for n minus 2 into A. These are the properties. It is useful in solving the problem. So you have to remember this easily, so you can solve the problem. So these are, now I am taking problems. How to solve problem of inverse matrix and adjoint matrix, and different kind of problems I am going to discuss, student. First of all, find inverse of the matrix. Just I am taking before you a question. Find inverse of a matrix. I am taking first. Find inverse of a matrix, that is equal to 2, 3, 2, minus 1, 0, 6, 1 minus 1 0. It is a order 3 square matrix. We have to find inverse of this matrix. So first of all, to get the inverse, we find cofactors and determinant. Cofactors. Determinant ले लीजिए 2 3 2 minus 1 0 6 1 minus 1 0. So find determinant. If you take 2, so you know this cancel 0 plus 6 and minus plus, here is a plus, this row cancel 0 and plus 2 and then it is 1 and this row cancel, this column cancel 18 minus 0. So 18 minus 0. So 6 to 12. It is 2 and it is 18. So this cancel 0 plus 6 1. A cancel 0 plus 2. This cancel 18. Okay. So it is 18 or 12, that this is 32. This is determinant A is 32. Now we find cofactors. We find cofactors of this C1 1 student. This row cancel, this cancel 0 plus 6 cofactor C1 2 minus this cancel 0 this cancel, so this cancel 0 plus 2 and so it will be minus 2 cofactor C1 3 cofactor of this row cancel, this cancel 18 minus 0 18. Now cofactor of second row cofactor C21 minus this cancel 0 minus 6, it is 6 C22 this cancel and this cancel, so 0 minus 2 0 minus 2 C23 minus, so cofactor of this row cancel, this cancel 12 plus 2 minus 14 C31 this cancel 1 minus 0 1 C32 this cancel minus 2 minus 3 so minus 5 C33 this cancel 0 plus 3 so we can find adjoint of A is equal to, just you write in first column 6 minus 2 18 6 minus 2 18 and 6 minus 2 minus 14 and 1 minus 5 3. This is adjoint A. So A inverse is equal to A inverse is equal to equal to adjoint A by determinant A. So now in final answer we are getting 6 minus 2 18, 6 minus 2 minus 4 minus 14 and 1 minus 5 3 by determinant A 32. This is the answer. So student, in this way you can solve the problem of this second pattern if A is a square matrix of order to -1, 2, -2, so that A square 3A plus 4I2 0 and hence find A inverse. This pattern is also important for examination point of view. If A is a square matrix of order 2, so that A square 3A 4I2 is equal to 0 and hence find A inverse. So first of all we will show this, then we proceed for that. So proof for this we find A square, A into A, -1 -1, 2 -2 and -1 2 -2. So this and this -1 1 1 -2 -1 into 1 1 -2 element, then 1 -1 1 and minus plus 2 and then 2 into -1 -2 -2 -4 and 2 into -1 -2 plus 4. So A square is equal to -1 3 -6 2 A square. Now 3A, so 3A will be -3 6 -6 4I2, so 4 0 0 4. Now substitute the value here. So LHS is equal to, so A square 3A plus 4I2, substitute the value A square -1 3 -6 2 and 3A -3 -3 6 -6 and 4I2 4 0 0 4. So what I am getting, -3 -4 -4 0 and it will be 0. So 0 0 0 0 matrix. So it is proved. Now hence find A inverse. For this we will prove. First part is proved. Now we proceed for that. So for second we will do in this way. Hence find. So first of all A square 3A plus 4I2 0. So here we do A square 3A minus 4I2 we write in this way, minus 4I2, then we multiply with A inverse. A inverse A square 3 A inverse A and minus 4 A inverse I2. So here A inverse into A in one A inverse A in into matrix I2 minus 4A inverse. So A inverse into matrix A 3I2 minus 4A inverse. So A matrix is, you know, A matrix is minus -1 2 -2 and 3 0 0 3 minus 4 A inverse. So we can write, so we have final, so -1 or 3 2 it is 0 or 3 and -1 2 -1 0 -1 and 2 or 0 2 -2 or 3 1. This is minus 4A inverse. So A inverse is equal to 1 by -4 2 2 -1 1. This is the process to find A inverse. ये second pattern है to find, hence find A inverse. Then we have to follow this method, this process, say find A inverse, not by line A by determinant A. So if this type of questions are there, then we have to maintain this process. Second question I am taking for you. Second, that is third question. If A is 3 7 1 5, find X and Y such that A square plus xi ya A square xi ya, hence find A inverse. This is the question. Next pattern, here we have to find x and y, then find A inverse. So we will proceed for that. First we find solution. A square, that is 3 7 1 5 3 1 7 5. Do multiplication, student. So 3 3 is 9 and 3 3 is 9 7 and 3 into 1 3 5 and here 7 3 is 21 7 5 is 35. So this into this 7 and 25. So we are getting Nosa Solar 8 or 6 and then 6 56 circle bar 32. This is A square, then xi xi is equal to x 0 x and ya is equal to that is 3y y 7y 5y. Now substitute the value substitute the value so a square 16 8 56 32 a square and x 0 x and it will be y 3y 7y 5y. So 16 plus x 8 56 32 plus x that is 3y y 7y 5y. So y is equal to 8 and 16 plus x 3y 16 plus x 3y. So 16x 3 into 8. So x is equal to 24 minus 16. X is equal to 14 में से 8 8. So x is 8. So answer x is 8. Y is 8. Now hence find a inverse. You can do. Here is a similar method you can do. A square x is 8i and 8a. From this you can find a inverse. So now you can solve problem of NCERT book. NCERT book problem you try exercise 4.5 homework. Exercise 4.5 NCERT. Thank you.